Welcome to PowerTech, your go-to source for all things power conversion. In this episode, we're going to explore the topic of control and power converters. In the context of power supplies, open loop and closed loop control refer to two different methods of regulating the output of the supply. Open loop control is a simple method where the output voltage is set by a fixed ratio of the input voltage. There's no feedback to adjust for any changes in the load or other external factors. This means that the output voltage can be affected by changes in the input voltage, temperature, the load itself. Also, it may not be accurate or stable over time. Open loop control is often used in simple power supplies where accuracy and stability are not critical. Closed loop control, on the other hand, is a more sophisticated method where the voltage is constantly monitored and adjusted to maintain a steady and accurate voltage, regardless of changes in input voltage, temperature, or load. This is achieved through a feedback mechanism that measures the output voltage, compares it to a reference voltage. This signal is then fed to a control circuit that then adjusts the output voltage as necessary to maintain the desired voltage level. Closed loop control is commonly used in high precision applications that require precise and stable voltage levels. We are able to implement either of these control schemes in the analog or digital domain. Analog control to power converters is a more traditional method of controlling the output. In this method, the output is controlled using a control circuit that is composed of a few passive components, such as resistors and capacitors. This makes it very easy to implement, in particular for simple control schemes. Additionally, analog control has a fast response time, which is important for certain applications. Examples of this are motor balancing, load balancing, and motor control. However, analog control also has some disadvantages. For example, it's susceptible to noise and other forms of interference, which can cause the output to become unstable. Additionally, analog control can require complex compensation circuits to stabilize the output power under different load conditions. If you're implementing a relatively complex or advanced control scheme, the size and cost of the analog circuit can be relatively large. It starts to make sense to use a digital control scheme in this scenario. Digital control is a more advanced method of controlling power converters. It's become increasingly popular in recent years, primarily due to the fact that the microcontrollers and the DSPs, digital signal processors, used to implement it have come down in cost and make it competitive with an analog design. The big advantage of digital control is that it's able to provide optimal operational conditions for the converter under a range of load and input conditions. It's also got a very accurate and stable output, and is able to implement complex control algorithms in a relatively small space. However, digital control can also be very complex to implement. Part of this is due to the requirement for the microcontroller itself and the relevant code. Additionally, digital control has a slow response time when compared to analog control. Some digitally controlled power supplies offer remote or cloud-based operation. Remote control power supplies are power supplies that can be controlled or adjusted remotely through a digital interface, such as Wi-Fi, Ethernet, or a USB connection. These power supplies provide the flexibility to adjust the voltage and current output to meet the changing needs of the device then powering. It makes them ideal for use in a variety of applications. One of the primary advantages of remote control power supplies is that they're able to adjust the output remotely. This can be particularly useful for devices located in difficult to access locations, ones that require frequent adjustments, or perhaps the device is located in a hazardous environment. Additionally, remote control power supplies often come with software that allow for detailed monitoring and analysis of power usage. This makes it easier for plant operators to optimize power consumption, reduce energy waste, and perhaps identify failures. Applications of remote control power supplies, they're widely used in a variety of applications, including scientific experiments, industrial processes, the entertainment industry, and horticulture. For example, in research labs, they're used to control the power output of sensitive equipment, in manufacturing facilities to control the power to various machines, in live theatrical productions to control lighting and sound systems, in horticulture to turn on and off lights to maximize yield rates. The future of remote control power supplies. As the technology continues to advance, we expect to see remote control power supplies becoming even more sophisticated, with advanced features such as real-time monitoring, automatic adjustments, and improved safety features. Additionally, the growing trend towards connected devices and the Internet of Things, IoT, means that remote control power supplies will likely become even more ubiquitous, making them an essential component in the connected world of the future. And that's it for today's episode of Power Tech. We hope you've learned something about control and power converters, and join us next week for another exciting episode. Until then, keep powering on.